Hey everyone, this is Top 3D Shop. In this video, we'll tell you about the Raise3D E2 3D printer. The company's been on the market since 2015, and during that time, Raise3D established itself as a manufacturer of reliable and easy-to-use professional 3D printers. In addition, Raise3D offers its free proprietary IdeaMaker slicer, which is not only tailored for their products, but also capable of slicing models for third-party 3D printers. Raise3D also has a full-fledged cloud service, RaiseCloud, with enormous possibilities for managing printers over the internet. You can use it to start printing, control the process, keep statistics, set tasks, make time-lapses, and more. Like the IdeaMaker, RaiseCloud is free. And with a dedicated Octoprint server, RaiseCloud allows you to manage printers by other manufacturers as well. All this makes it possible to use Raise3D printers in a convenient and functional ecosystem. The Raise3D E2 comes fully assembled and ready to use in a rather large box. On opening it, we see a quick start guide, a set of hardened steel hex keys, and 5 power cables for different outlets. The outer dimensions of the device are 607 by 596 by 465 millimeters, and it weighs 35 kilograms. When turned on for the first time, it is necessary to go through some simple procedures for calibration and initial setup. All steps are described in detail on the printer screen and accompanied by videos. After removing 4 transport locks, the Z-axis lifts up, and you can get a box with the rest of the accessories. It has everything you need to use and maintain the 3D printer. A quality metal spatula, tweezers, spare fittings, fuses, and Teflon feed tubes. 16GB USB flash drive, steel card for calibrating gaps between the print bed and the extruders, long nozzle cleaner, heat-resistant gloves, and 2 spools of Raise3D red and white PLA filament. Following the on-screen instructions, we need to load the filament into the printer and launch the initial calibration. The whole process is extremely simple and well-defined. Ultimately, the machine will print a simple test model, a spinner. In our case, the model turned out great, which is not surprising. Let's take a closer look at the printer. Like other printers by Raise3D, it is completely enclosed and has a so-called passive heat chamber. The temperature inside is maintained by heat from the print bed. This is essential for printing high-temperature filaments that tend to shrink. When printing with low melting point materials like PLA, it is advisable to open the top cover. Then the warm air will be escaping without overheating the filament. The front of the printer, too, has a door that opens to the side. Both the top cover and the door have transparent panels that allow you to monitor the printing process. On the sides of the printer are convenient carrying handles and filament compartments. Before using them, you need to install special holders from the kit, on which the spools will rotate. The back wall of the chamber houses an exhaust fan and a replaceable HEPA filter with activated carbon, which eliminates harmful fumes from certain types of thermoplastics. The most important feature of the E2 is definitely its IDEX system, which stands for Independent Dual Extrusion. First, it allows conveniently printing 2 color models, or those made of 2 different materials, for example, with soluble supports. Besides, in contrast to most conventional dual extruder printers, you don't have to waste a lot of material when changing an extruder. And when printing with a single extruder, the other one moves aside and does not get in the way. Secondly, IDEX printers have 2 interesting print modes. Duplication, in which both extruders simultaneously print the same models on different sides of the bed, and mirror mode, in which the second extruder prints a mirrored pattern. When printing with a single extruder, the build volume stands at 330 by 240 by 240 millimeters, while in dual extruder mode, the x-axis is reduced to 295 millimeters. When using mirror or duplication mode, half the print bed is accessible for each of the extruders. The Raise3D E2 uses Prusa-like kinematics. At first glance, it might not seem like the best solution for a professional 3D printer. But in the case of 2 independent extruders, this certainly has an advantage over other types of gantry systems, as the extruders don't have to constantly move with the X-rod along the Y-axis when printing. This way, the weight of the moving elements is evenly distributed between the bed and the extruders. The heated bed is made of aluminum and has a thickness of 5 millimeters. The magnets all over the area hold a removable, flexible steel plate covered with the built-tack adhesive surface. The bed moves along 2 8mm rods with linear bearings and is driven by a NEMA 17-stepper motor through a 6mm Gates belt. The maximum bed temperature is 110 degrees Celsius. There are no knobs to level the bed. As with all Raise3D printers, it is factory calibrated. Although you do have the possibility to recalibrate the bed using 5 screws under the print bed, there is usually no need for this. In addition, the printer has an auto bed leveling sensor. It is worth noting that all elements of mechanics and electronics are made of high-quality components, which undergo strict quality inspection. The wires are neatly placed in cable channels and chains, nothing is loose or sticking out. The Z-axis moves on 4 8mm rods, 2 on each side. It's driven by 2 motors with 8mm double-start lead screws. And because the motors are not synchronized with each other, the printer has an automatic leveling function. The Z-axis moves up and touches the top beam until it's horizontal. The grinding sound produced during the process is normal, so don't be alarmed. The extruders move along the X-axis on a single 12mm rail guide from the Japanese manufacturer THK. Each extruder has its own motor and its own 6mm gates belt. Each side has an optical end stop. By the way, all the end stops on this printer are optical. Now let's expand on the most interesting part, the extruders. The extruders in the E2 are direct drive, which means that the motor with the feeding mechanism is located on the print head. This makes it easy to print with almost any filament, including flexible ones like TPU and TPE. The maximum temperature of the extruders is 300 degrees Celsius. The printer supports a wide variety of materials, but keep in mind that when printing with composite filaments, it is better to use hardened nozzles. Both extruders are quite easy to remove. If you need to perform maintenance, all you have to do is unhook one cable and remove 2 screws. The feeding mechanism of the extruder is fairly interesting, with a single feed gear similar to the one used in the BMG feeders. But on the other side, the filament is pressed to it by a smooth roller, with the possibility of adjusting the pressure. The gaps between the feeding gears and the input to the hot end are minimal. A large pinion on the top allows you to manually push the plastic without having to use programmed filament loading and unloading, which may be rather convenient. The cold part of the extruder is cooled by a 3010 axial fan, while a 4010 turbine fan is used to cool the print area. The air duct is single-sided. The first extruder has it on the left, and the second on the right. All of the printer's fans boast high quality. They are quiet and don't vibrate. The shortcoming of the system seems to be its weight. The metal parts and the motors add up. The extruders weigh about 400 grams each. This means you can't print fast on this printer. Also, there might be some print defects, such as echoing after turns. We'll see how much of this will occur in the tests. The left extruder has an auto-leveling sensor on the side. It resembles BL Touch, but is much more efficient. Thanks to this sensor, the first layer should be perfect, provided the offsets are calibrated correctly. Last but not least, the electronics. All of these are housed in the upper front unit of the printer, which uses 2 boards. The first one is based on the popular Duet Wi-Fi, with the 32-bit Atmel microcontroller running at 120 MHz. It's responsible for motion control and printing. The device uses silent stepper motor drives from Trinamic. This board runs on modified RepRap firmware. The second board is responsible for the touchscreen and the user interaction with the printer. It has a quad-core 1 GHz NXP processor running on Linux, so it's basically a full-fledged computer. The printer has a 7-inch touchscreen with a resolution of 1024 by 600 pixels. It employs a resistive yet very high-quality sensor, perfectly responding to taps. The user interface and its options are really impressive. It's definitely one of the most convenient interfaces we have seen. All the necessary information is always at hand. You can change the print or temperature settings in a couple of taps. You're free to adjust motor steps per millimeter, PID parameters and their auto-calibration, accelerations, jerks, motor current, and much more. You can also connect the printer to your local network via Ethernet or Wi-Fi. And if you have internet access, the E2 can be connected to the RaiseCloud service and managed via the internet. There's also a built-in camera allowing you to watch the process from anywhere. The image quality is not the best, but it is enough to notice a problem and, if necessary, to stop printing. The printer receives firmware updates over the network and installs them by itself, so you don't have to write firmware to a flash drive, though it is also possible. In general, the electronic components of the E2 are one of its strongest points, just like in other Raise3D printers. Now let's move on to the printing tests. The first and most obvious mode for this device is dual color printing. To let the machine know where the 2 extruders are relative to each other, it is necessary to go through a calibration process. Here, as with the initial setup, you can find pre-configured test patterns. Go to the Setting menu, Maintenance, and Offset Calibration. Load both extruders with PLA filament, preferably from the kit, and go through the 5 calibration steps. We won't waste your time and show them all, as everything is explained in detail on the printer's screen. First, you need to measure the distance between the left nozzle and the heat bed when the auto calibration probe is triggered. The second step is to do the same for the right nozzle. After that, the printer will perform 9-point bed leveling and show us a visualization of the bed flatness. In our case, the bed was pretty level. The deviation was only 0.07 millimeters, which is enough for hassle-free printing. Next, the printer will print 2 models with both extruders, so we can determine the distance between the nozzles. The calibration will end with a small 2-color model. If the previous steps were done correctly, all sides of the model should be flat, with no protruding corners or gaps between colors. Now the device is ready to print with 2 extruders. Our first test was a dual-color octopus from PLA. As one of the extruders stands by and waits for the other to do its job, the filament can slightly leak out of the nozzle. To deal with this, we've added what is called a wipe wall around the model. That way, prior to printing the model, the extruder will pass over this wall, the filament will reach the nozzle, and it'll be ready to print. In addition, the leaked filament will remain on the wall. The model turned out great. The octopus has a lot of small areas of different colors. Besides, it is hollow. There was a lot of backtracking during printing. Even so, the colors match perfectly, there are no plastic streaks, the slopes are fine, the top of the head closed smoothly, and the cooling of the print area worked well. Considering the complexity of the model, the machine did a great job. For the next test, we tried out the duplication mode. It was decided to print chess pieces as an illustrative example when printing the same models in different colors can be useful. We took incomplete sets, only 6 pieces for each color, but this was enough. These chess pieces also have elaborate design features. They can clearly show the quality of retraction and printing of slopes. For the duplication mode, the manufacturer recommends using a raft, so even if the extruders are at different heights, there will be no issues with the first layer. We followed this advice and added a raft. The machine handled the chess pieces fine. As the models turned out to be low polygonal, somewhere you can see the edges of polygons. And unfortunately, the cooling in some places was no longer able to cope. Areas with steep slopes, which were on the opposite side from the blowing, did not have time to cool down properly. Because of this, the corners were slightly elevated. Even so, all parts were printed through and nothing broke. There are no strings, so the retraction worked as it should. The layers are laid evenly. Overall, the result is acceptable. And thanks to the duplication mode, the chess sets were printed twice as fast as they would have been one by one. Next, we ran the print in the mirror mode. For this test, we took a part of a radio-controlled car. These are the suspension elements, which are essentially the same, but symmetrically reflected relative to the center of the model. The parts were also printed with a raft. It's worth noting that the mirror printing looks quite spectacular. The parts look good too. The holes are flat and the layers are evenly stacked. If you look closely, you can see a slight echo on the x-axis due to the heavy weight of the extruders. Still, the echo is minimal. You can see it in the light only and it isn't felt to the touch. The y-axis has no echo at all, which is very nice. When printing these and all other models, we used ready profiles from the IdeaMaker slicer. The speeds there are not very high and it is advisable not to increase them. Otherwise, the echo will become more evident. And the last mode of dual extruder printing that we wanted to test was printing with water-soluble supports. In our case, it was PLA plus PVA. So we took this intricate model. It's sort of a maze that is printed in its entirety with a small ball to roll around it. It's nearly impossible to print this object without water-soluble supports, because removing them would certainly break the model. Since PVA filament is quite capricious and prone to leaking out of the extruder when the latter is idle, we added a small tower to the wipe wall. It performs the same function, but is positioned away from the model. Plus, PVA is very soft and elastic, so we could test whether the E2 could print with flexible filaments. It took a very long time to print the maze, about a day and a half. The model didn't look nice as it was printed. There were clots of PVA leaking from the nozzle, and the wipe wall was breaking in some places because PLA poorly sticks to PVA. But all of this is typical for similar projects. What really matters is, the main model was printed clearly and evenly. Sure, it wasn't necessary to make all the supports with PVA filament. We could have used it only for the bonding layers between the model and the supports, but we wanted to give the printer a real stress test. After the printing was done, we dipped the maze into a basin of warm water and let the PVA soak. We didn't wait for complete dissolution and simply removed all the supports from the model. The maze was printed splendidly. The supported areas came out almost perfect. Without water-soluble supports, it's just impossible to achieve this quality of surfaces. As planned, the ball can safely roll around the maze. The model, though useless, is spectacular and revealing. Clearly, low melting point materials are not the only option for the printer's users. So let's try out more difficult plastics. With ABS, we tried to print a small box. It consists of 2 main parts and 2 small latches. Of course, we closed all the printer doors to keep the required temperature in the chamber. As expected, the task was no problem for the E2. The box was printed just fine. The layers are stacked perfectly, there's not a single skip or clot of filament, no strings either. And thanks to the enclosed chamber, even the shrinkage-prone ABS didn't warp. Nothing peeled or cracked in spite of the fact that the air blowing was on 50%. The box was easy to assemble, and it works as it should. Next, we made a nylon carabiner. The model itself is small and simple. There were no problems with it either. We observed a few leaks of plastic after transfers, but that happens with nylon, so it's not the printer's fault. The carabiner was also assembled without difficulty, and it's functioning well. Finally, we printed a polycarbonate part. This is a seat adjustment knob for a car. The part was printed on the first try and came out very well. There's pretty much nothing to add. Everything went fine. To sum up, the Raise3D E2 is a serious, professional device assembled from quality components. The electronics deserve particular attention. The user interface and network capabilities are just outstanding. The printer is convenient and nice to use. The only disadvantage of the E2 is its heavy extruders driven with thin belts. Because of this, the printer is quite slow. However, it did cope with all the tasks we set. The Raise3D E2 prints great, though not fast. This is Top 3D Shop with the Raise3D E2 3D printer review. Subscribe to our channel, leave comments, and hit the like button if you've enjoyed the video. See you soon!